Hey guys, welcome to section 2, chapter 2 of the geometry program. This section is all writing, and so I went with a Google Slides presentation in order to ensure that you can clearly see everything that we're writing for this section. So in section 1, we talked about conditionals and the converse. And we hinted on the idea that if we assess the truth value of both the conditional and the converse, and they're both true, then we can write them into something called a biconditional. Biconditionals are a statement created when both the conditional and the converse are true. And you write it by combining them with an if and only if statement. Okay? You're going to see what I mean. Obviously, I'm going to be able to talk faster than you write. So pause the video to make sure that you can get down everything on the slide before moving on. So here's an example. Let's take the conditional. If a triangle has two sides of equal length, then it is an isosceles triangle. Last section we learned how to write the converse. The converse takes the conclusion of the conditional and makes it the hypothesis. So it switches them. So the converse would be, if a triangle is isosceles, then it has two sides of equal length. All right, in order to write the biconditional, we have to assess whether both of these are true. And in fact, they are. So if a triangle has two sides of equal length, then it is by definition an isosceles, and an isosceles by definition has two sides of equal length. So those are both true. So then the question is, how do we write them in an if and only if statement? And this is how. So the biconditional is written by taking the hypothesis of the converse statement and writing it as the new hypothesis, and then the hypothesis of the conditional as the new conclusion. Take a minute to write that out. I'm going to show you that it's actually much easier than it sounds. But students often confuse the information when writing the biconditional, so I just wanted to be clear here. You're going to take both of the hypotheses and you're going to form the biconditional. All right, so if you take the hypothesis of the converse, it is a triangle is an isosceles triangle, and then the hypothesis of the conditional, and you would get has two sides of equal length. So when we write that, a triangle is an isosceles triangle if and only if it has two sides of equal length. Okay, I know that was really wordy. We're going to do a couple more examples. All right, so let's take a non-wordy example. So let's say if 2x minus 5 equals 11, then x equals 8. I want you to take a second and practice in your notes what the converse is going to look like. Pause the video for a second. Okay, hopefully you guys wrote the converse like this. If x equals 8, then 2x minus 5 equals 11. All right, now we need to decide if we're going to write the biconditional, both of these statements have to be true. And of course, these numerical statements make it easier. Yes, they are both true. So if 2x minus 5 equals 11, then you could solve that and get x equals 8. And if x equals 8, you could plug that in and you're going to get 11. So both of them are true, which means now we can write the biconditional. And the biconditional takes the hypothesis of the converse. So x equals 8. If and only if, then the hypothesis of the conditional, 2x minus 5 equals 11. All right, hopefully that was a little bit clearer. Let's do another one that doesn't work, actually. So here's the conditional. If x equals 4, then the absolute value of x is 4. If you take a second, I want you to try to write out the converse of that statement. Okay, then the converse is if the absolute value of x is 4, then x equals 4. But if you think about this for a second, that's not true, because we can think of another value for x such that the absolute value is also 4. So in this case, we could provide a counter example where x could equal -4 and the converse is not true. Therefore, we cannot write a biconditional. So both the conditional and the converse must be true in order to be able to write the biconditional. Make sure that you write that down in your notes, like star it, highlight it, like that's really important. So this would be an example where the converse is not true, and therefore we cannot write a biconditional. All right, so in your assignments, I think it would say something like, please write if it's not reversible or something. And in this case, it's not reversible. Okay, and then the only other thing you have to do, you're going to have statements, you're going to have to write the conditional, the converse, and then the biconditional statement. And the only other thing that you need to do is to be able to write two statements from the biconditional, essentially meaning you have to go backwards. So we've been taking information and combining them, but now what happens if they give us the biconditional? So here's an example. So two angles are congruent if and only if they have the same measure. All right, so we have to create two statements from this. And if you can remember how we combined the two statements for the biconditional, you can deconstruct it in the same way. So remember, the hypothesis of the biconditional was the hypothesis of the converse, and the conclusion of the biconditional was the hypothesis of the conditional. So let's look at that. Notice that the hypothesis of the biconditional is my hypothesis of my second statement, of my converse statement, and that the conclusion of my biconditional is the hypothesis of my first statement. So if you have two angles of the same measure, then they are congruent. In the second statement, if two angles are congruent, then they have the same measure. All right, that is all for this section. It's just combining these logic statements and assessing the truth value. So hopefully that should go pretty easily for you. There are several other examples in the book. So go back, make sure that you have written all of this out in your notes. Make sure that you're reading through the examples in your book, and then begin your assignment.